Hey, how's it going, everybody? My name is Omar Soliman, and I'm going to be presenting just the overall introduction of the project and just giving a basis of what it is and the uses for it and everything like that, and why we kind of chose this project. And I'll just be going deep into um, some of the problems that we faced, the methodology, integration, and just like basically a general view of the project, if you would say. And so I'll just start off with introducing. Um, so we saw that in an increasingly interconnected world, effective communication across language barriers is essential for collaboration, understanding, and progress. And so our project aims to develop a real-time language detection and translation system that facilitates seamless communication between users, regardless of their native languages. By harnessing the power of machine learning and leveraging data sets like Google MT5, we wanted to create a solution that can accurately detect the language of incoming messages and translate them into the desired language in real time. Um, so the project holds the promise of breaking down linguistic barriers and fostering greater cross-cultural understanding and cooperation. And so that's basically what the project's about and everything. And I'll just go over the methodology. So to start off, we'll start off with data collection. So our project utilized the Google MT5, like I said, the pre-trained model, and the Asian language tree bank data set provided through Hugging Face, um, which is a multilingual translation model capable of translating between 101 languages. And so we use this for like a couple of the languages in the project. So this model was chosen for its versatility and performance in handling various language pairs. The data set used for training was a subset of the Google MT5 training data, which contains a diverse range of sentence pairs across multiple languages. This data set provided sufficient training examples to train the machine learning models effectively. And so I'll just move on to the development of the model. And so there were two main components that were developed. The first was the language detection model, utilizing algorithms such as n-gram language models, naive Bayes classifier, and fast text. And there was the second, which was the translation engine, which employed techniques like neural machine translation and statistical machine data. Um, and so, yeah, I'll move on to integration. So for integration, the language detection and translation models we use that are used to integrate um, with RESTful APIs and WebSocket communication. They facilitated seamless interaction between the front end user interface and the back end models. Um, and so for testing and evaluation, we did rigorous testing to access the accuracy, performance, and responsiveness of the system. We did various scenarios that were simulated to evaluate the system's ability to handle different languages and dialects, and of course the input formats. And so for our results, the develops the system that we developed demonstrated great results. Um, the for one, the language detection, we achieved high accuracy in identifying the language of incoming text, even in cases of ambiguity. Translation, we provided accurate and fluent translation between multiple languages with minimal latency. And then the real-time integration, we enabled users to input text and receive translations instantaneously, enhancing user experience and usability. Um, and so I'll just go over some of the issues that we faced. We faced several challenges and areas that we definitely did need improvement in. First one being ambiguities. Handling ambiguous language detection cases remains a challenge and requiring further refinement of algorithms and strategies. So this can be developed further in the future, of course. Um, and so moving on to the second, which is scalability. Uh, like I said, as the user base grows, ensuring the system's scalability and resource efficiency will be crucial to maintaining the performance of everything. Um, and so as for accuracy, since this was a small scale project, we were only able to utilize small scale data sets and models, which caused inaccuracy and unfinished results when we tested using various cases. And so for user feedback, we incorporated user feedback mechanisms and iteratively improving the system based on user input. Uh, we kind of just thought it would be essential for long-term success. Um, and so, yeah, that's basically everything. And so, to wrap up everything I've been talking about, the development of the real-time language detection and translation system represents significant advancement in bridging linguistic divides and promoting global communication. By leveraging machine learning algorithms datasets, we have created a system capable of accurately detecting and translating text in real time, thereby facilitating seamless communication across diverse linguistic backgrounds. While challenges remain, ongoing refinement and improvement efforts will ensure that the system continues to meet evolving needs of users and contributes to greater cross-culture understanding and collaboration. Um, and so, yeah, that's basically everything for my part. I'll pass it on to the other guys so they can explain a little bit more in detail of what the project consists of.
Hello, my name is Isaac, and I'll be showing you our model, our training machine learning model that we used for uh, natural language processing, our natural language processing task, which was translation between different languages. And so what we have here is basically um, a model which breaks down. So what we have is input text. So it's you input a text. And so a generalization of how this model works is it breaks the text down into tokens. And so each part of like the string has its own like token value. And then it basically compares it to the other token values of other languages so they can match. Like let's say hello had a token value of 5, and then it looks through like the data set and looks for a token value of 5, and then it tries to match it, and then it translates it into the other language. So what we have here is, so we used the pre-trained Google MT5 small model because the small is less data and it was easier to train. And then we just tokenized that model. We used the Asian language tree bank data set, which is at least that data set limited itself to mostly the Asian language. So what we have here is Japanese, Chinese, Hindi, um, Indonesia, Philippines, and Thai, and two other I forgot. And so what we have here is basically this first function encodes the input string. So like I said, it grabs the input string and then breaks it up into tokens and assigns a value to each token. Same thing with the target string. This target string is actually from the alt data set. And so the alt data set has like sentences that we use to train our model. Basically like it already has like pre defined sentences that it goes through and it's like, oh, this word equals this token, that word equals that token. And so that's what basically it's doing. Right now we're going to be comparing the input string tokens to the target string tokens. And so what we have here is the format translation data, in which it basically organizes the data by selecting a random input. Like for training, it grabs a random language and then compares it with a random output language. So they can go through all the languages that we've listed and like fine tune it, making sure that everything is how it's supposed to be. And so here we have the transform batch, which just basically handles the batch of data, um, and just puts it through the GPU. And so the get data generator basically just simplifies how the data is inputted into our model. So instead of loading the whole alt data set, it goes, for each batch, it loads what it needs to load. So we don't, um, so it doesn't take up as much uh, storage space in like memory. And so here we actually have the training. And so since I already did train a little bit, I just had to load the what we already trained. And when I was playing around with it, at first it was pretty bad. But then I switched over to 10 epochs, which kind of fine-tuned it a little bit. So we just have, a bunch of optimizer, scheduler. The eval mode basically just evaluates the progress of our model, like the loss and the progress and basically all that. And then here it actually goes through the actual like, the training process where it uses everything we already built and then it just goes through it and then here it prints out um, the progress and then we just save it into a file and that's basically it. So once again, we just used a pre-trained model and then we just fine-tuned it using the alt data set. So we chose these languages to train. And it basically breaks up the sentence into tokens and it compares it, well, during training, it compares it to other random sentences or languages that it chose. And then, it basically, I forgot the word, but basically like connects, this word equals that word in that other language.
All right. Hello, guys. My name is Sebastian, and today I'm just going to be giving the demo for the project that we've been working on. So here we have the main front end. So we have our chat application and we have a random user created. And here we're just having two pages to simulate the chatting feature. So we're able to translate our messages, which you can see through here. But for now, just to demonstrate the functionality of our website, I'll just give a simple hello message here, sending it on user 370. And now we see here that it updates on both pages. So user 370 sent a message, and now our other user here is able to see that message. So what makes our app special is that we have the ability to translate our messages. So we have our origin and target language. So the goal here is to pretty much have these real-time translations so you can talk to anyone despite of any language barriers. So here, let me just get my first message. So we can do from English to, let's see, we can do to Japanese. And then we'll send our message here. So did you watch the soccer game yesterday? We'll send that. And there we go. So now it translated our message since we set the target language to Japanese. And here's our Japanese message, and it says translated from English. So that's what we wanted to do. And it shows it on the other user page as well. So we can assume this user speaks Japanese, for example. Now we can talk with them, which is a pretty cool feature. And here we can send another message. So we can do now our origin language. It can be from Japanese to English. And we'll put in our message here, send it. And then, yeah, it says here, here's our reply to the previous message. And we can see it was translated from Japanese and now it's in English. And let me just do one different language here. So we can do from English to Hindi. We can put in our message here and translate that over. Here we go. So now we translated over from English and we got our Hindi message. So this is a pretty neat application since, like I mentioned before, you can talk to anyone you want. You just choose the origin language and the target language, and the translations are pretty quick. It's like 1 to 2 seconds. So the goal of this is just to create seamless communications to make it easy to talk with people, even if there's a language barrier. All right. So as you saw, with the use of our machine learning algorithms and data sets, we have been able to create a tool that's capable of quickly and also accurately translating text across linguistic boundaries. The time that we spent developing this real-time language detection and translation system, it can be seen as a small but yet important step towards helping bridge the gap in global communication. Along the way, we did discover a few challenges as we work with this, especially with the model proving to have a few limitations. These limitations included cases where ambiguous language was involved. This tended to lead to inaccuracies in our results. However, these drawbacks do open the door for improvements to be made, which, if we were given more time to work on this, we would include more training of our model by including more and larger data sets so that it can broaden its understanding of these translations and it would have a better overall accuracy. By looking ahead, the integration of user feedback mechanisms could also stand as an important step in improving the accuracy of our model. So this would work by, let's say a user writes in a message and the translation is incorrect. Well, the user would have the ability to say, hey, the translation is incorrect. This is what it should be. And we would receive feedback that way. And based on the feedback, we can improve our model. So basically, by engaging with our users, we can then be constantly refining our system based on the input that they give us. And this can ensure the relevance and efficiency of our model in making proper translations, since languages tend to change over time. And now, with our newfound understanding of machine learning models and the other skills that we learned throughout the development of this project, we are now more experienced and confident than ever to improve upon this tool. And we would like to increase the scalability as the user database expands. We would also like to port the project to a website so that many people can use it, since right now we're just running it locally. We'd also like to include a feature where we have multiple chat rooms so that it's not just a single chat room, but now users can have private and secure chats with their friends from around the world. And so our development of this tool doesn't necessarily end here, but rather it has just begun, and there's a lot of improvements that we can make in the future.